Okay. So let's see what this does here with this complete graph. Oh, come on. This is really looking crazy. What is it doing? I mean, so presumably
Pretty sure
something...
there are some bugs in recent build of 12.1 which interact with this.
Okay, well, let's try.
Which version do you have, by the way? Okay, same as mine. It's possible it only appears in this one.
Well, shall I try the prototype build? Let's try the prototype build just for the hell of it. I do love the way that the prototype build has these little crosshatches, you know, on that button. It always seems to have that. Okay, not good. So I'm guessing that this is a change in community graph plot. Let's take a look at the 12.0 story. Okay, but then, so basically we want the existing hypergraph plot to be, I mean, are we going to have separate ordered hypergraph plot and hypergraph plot? Okay, look at that. That's different. I don't think I like the choice of colors, but that's definitely different.
Well, the problem is not the color. The problem is there is no vertex layout whatsoever.
What do you mean there's no vertex layout?
It always puts vertex on a grid. Just try it with a very large graph.
Well, but look at the code. The code, look, there's the code. It's very small.
Interesting.
Community graph plot. Community region style. Okay, so most of tuples. I don't understand that. Do you understand what it's doing there? Well, I think we need to look
but
at...
I don't know what community graph plot does.
Let's see. It looks to me like what's happening. Okay, so that's the regions of those communities. I don't know. This looks like kind of a hack to me. Okay, but anyway, you think that the overall thing we want to do is to have a hypergraph plot and an ordered hypergraph plot. Is that true? Or are we trying to shoehorn those two together?
I think putting them together is better because that makes it easier to generalize later if you want to have partially ordered hypergraphs or something like that.
Okay.
So in the first version, we could just have edge type option, which would be equivalent to directed edges option in graph plot.
What's the option in graph plot?
Directed edges. So I think that's what it is. It just interprets the rule in different ways.
Okay.
So in our case, instead of Z, you will have H type option.
All right. I mean, given what we're actually doing, it would probably be nice to default it to ordered, but
Actually, it should default to cyclic open.
why?
Because it should, I mean, in the style we are using, it connects the last vertex to the first vertex, which makes it cyclic, but it's open, meaning that the last ones are not connected with a line.
Sorry, by the way, did we determine that Jonathan is not available right now?
Yeah, I think so. His
Okay.
flight, yeah.
I thought his flight was at 9 o'clock.
8.
8 Central.
Yes.
Okay. And it's presumably a big plane necessary to get across the Atlantic, so it's probably already boarded.
Yeah.
Okay. I see that he's got this function find network proof. What is that supposed to be about? That is the rule properties. So that's another rule properties function there. Find network proof. Max, do you know what that does?
Well, not exactly. I kind of know what it's for, but I don't know what it does right now.
Yeah, find calls on variance proof, I understand.
Oh, presumably find network proof is generalization of that, but I don't know exactly.
Proving some property of a okay, all right, let's come back to hypergraph block. Whatever this random hypergraph thing is, it seems like that should be I mean, like random graph, there must be many kinds of random hypergraphs. Although it does seem to me that we should have a function repository item for random hypergraph as well. Okay, n vertices and m edges. Oh, well, I see. So
it doesn't say what the length of the hyperradius is.
You mean how hyper they are?
Yeah.
Yeah, I don't think it's the right thing here, but I think we do want a random hypergraph, just like we have random graph. And let me just add that to my hypergraph
If you
functions.
have probably, if you are going to generate random rules.
Say that again?
If you are going to generate random rules, you probably have it as a side effect.
Yes, maybe so. We should look for that. Okay, hold on. Okay, Sushma, let's look for the random hypergraph thing and add stuff.
Okay.
But let me make a at least a stub here. You know, there's a certain argument that, like graph, has a, yeah, I mean, effectively, we are not, this isn't generating a random hypergraph, it's generating the rules for a random hypergraph.
What do you mean?
Well, because it doesn't have a hypergraph wrapper. Unlike graph, which has a graph wrapper. unless we introduce a hypergraph wrapper.
Well, it's not necessarily a bad idea. Then you can also plot them by default.
Yes. Maybe we should, and then we can store some additional stuff in the hypergraph wrapper. But we're still going to need a hypergraph plot because it's going to have lots of options.
Right.
But okay, look, we can have a wrapper called hypergraph. Okay. And in fact, that hypergraph wrapper could say whether the hypergraph, what type of hypergraph it is. See what I'm saying?
Yeah.
Could have a second argument that, I mean, does graph have such a thing?
I think in graph it's pure edge, but I don't know how it internally stores it.
What's this? Graph feature themes. The heck is that? Is that a plot theme for graph? That would be an interesting thing to have. By the way, Sushma, could you report that they're still talking about properties and it shouldn't be? It should be annotation rules.
Okay, yeah.
And I don't think that name should be properties anymore. Okay. Well, I mean, we could have, hold on, let me just store this. So the concept would be that we have a thing that is literally called hypergraph. This would be, I think, by default, probably an unordered hypergraph.
Why do you say rules?
You think it should just be lists?
Well, what kind of rules would it be?
No, it's edges there. It's
Yeah,
not
because rules would nest by default. So
okay. Hyperedges, the specified list of hyperedges. I mean, it is true that we could conveniently display would we then display the states from Wolfram model as hypergraph? I think we could. And then we could have that be by
Yes,
default.
if possible.
Right. But how do we go from the hypergraph to the list of edges?
Edge list.
Edge list, do you think?
Yeah.
Or presumably first in this particular case.
What first for me?
Of the hypergraph.
Well, yeah, but it's not. I mean, we shouldn't call it this way because
No,
it
I
might
agree.
change.
I agree. The following types of hypergraphs possible types of hypergraphs include okay, so we've got unordered.
No, these are just the name types.
What? Unordered, ordered, and cyclic.
Cyclic, yeah.
Elements in a hyperedge are unordered.
And I also heard from chemistry people that they want to have one which has two unordered pieces which are ordered with respect to each other.
Well, so that means they want an arbitrary, I mean,
that is inputs and outputs to a reaction.
I see. That's a mess.
What we really need is to be able to specify any finite group for each edge.
Yes. Right, but we have that in structured array. Right, we have an analogous thing. What's that?
Never heard of structured array before.
See, symmetrized array, antisymmetric, all that kind of stuff. Where the heck does it give the information on what? I mean, I suspect that we probably want symmetrized array is probably the right concept to use here. Right, that we can include a symmetrized array, you know, something like nodes, I mean, edges. But I don't understand where in the documentation here. Where does it say what the symmetries can be? What a stupid thing. Where's the symmetry? How does it, why is there no documentation about what the symmetries can be? Sushma, I think this is one for you to chase down.
Yeah.
I mean, this is very nice, don't you think?
Yeah, I think so.
And this should be able to, you should be able to just directly use these symmetric array things. mean, I'm thinking the symmetrized array, well,
it's a bit heavy though. I mean, we can have every edge to be an object.
depends how efficient these things are. But at least we can
Well, it
use
just
the
takes a lot
notation.
of space, even if it's not very slow.
Maybe, okay. But I mean, we certainly can have, okay, well, so here, most likely what we want to do is to say symmetry. Arbitrary.
But
Symmetry.
there's also a way to specify finite groups, you know, it's completely separate functions for that.
Wait. That's a permutation, right? So in principle here, we could say, make a list of equivalent permutations.
Well, it's not just permutation, it's a group.
Why isn't it just permutations?
It might have multiple generators.
I don't understand. I don't understand that. It's a permutation group, isn't it? I mean, it's something where there's a...
Yeah, it's a permutation group.
Right. But that could be, I see what you're saying, could be a list of equivalent of permutations that are considered equivalent. Or
yeah, there are already syntax to specify those. Let me find it.
Okay, but in any case, we need to get, okay, so we're going to have a hypergraph thing, and we can introduce that.
There's permutation group function.
I see, okay. Yeah, fine.
So we could have a hyper-edge wrapper, which would take this permutation group as an argument.
Well, we don't have an edge wrapper. Oh, we do have an edge wrapper. Yeah, we do. So you're suggesting that here we would have hyperedge. Now, in fact, this is a great reason, you know, we're just arguing about edge queue and whether we should put a list into edges because of tagging, right?
Yeah.
But you're suggesting here that this would be a hyperedge with a permutation group here.
Right. I mean, we don't have to call it hyperedge, we can just call it edge.
No, we can't. No, we can't. Not because an edge doesn't have, I mean, with an edge, there's a symmetry thing, but it's much simpler than this. Right? For an ordinary edge, it's either symmetric or it's not.
Yeah, but there's no, what I'm saying, we don't have to have a separate symbol for this. We can just use edge that already exists.
By the way, Sushma, are you recording this session?
Yep.
Okay. Go ahead.
Yeah, I'm saying, why can't we just use normal edge instead of hyper edge?
Because I'm telling you that normal edge has this weird stuff. You can't generalize to, because normal edge is varogs basically. And there isn't a normal edge. There's a directed edge and an undirected edge, right? See, look, it's got UVT.
All right, well, that wouldn't work. Wait, what? Oh, there is no edge.
There's a what?
The edge is not used right now.
I know. But I think it's too weird to use it.
Why?
Because it could be a million different things. I just don't think we should call it edge. It's too edgy, you might say.
Okay, I guess.
Okay, but let's come back to hypergraph plot, okay? So I think we've got this idea of a specification for a hyperedge, which we don't need yet. So the alternatives will be either the whole hypergraph has a certain symmetry specified, which we would burn in to the hypergraphs that come out of Wolfram model. See, I'm a little worried that, when we give the initial, I guess with Wolfram model, we could, what goes in could be pure lists which are assumed to be ordered hypergraphs, right? Like the initial condition and so on.
Yeah.
Okay, but let's go to hypergraph plot, right? Where, let's see, do I have, let me make another hypergraph plot thing here.
Yes, I was trying to make it similar to graph plot, but I realized it leads to bad result.
Why?
Okay, here's the problem. So in graph plot, there's separate stages for doing things. There is layout, there is what is called edge shape function, and then there is style. So this is a problem with it. Layout produces something rough. It doesn't know anything about shapes of vertices, for example. And then when we try to use those with edge shape function, it doesn't work because edge shape function treats every edge independently.
I see. Well, so
and is there any kind of, actually, even for ordinary graph plot is not good because there's an issue with arrows. So arrows supposed to end at the edge of the vertex, not in the middle of the vertex.
Yes.
But the edge shape function returns curves that end in the middle of the vertex because, I guess it doesn't know the vertex sizes.
Right. Well, I've noticed issues from this, right? So you should point these out to Charles. Okay.
Well, I could point this out, but I don't know what we can do at this point.
Well, I don't know either, but I think you should point it out and ask what because he may have already thought of something. Okay.
Right. But I think you should just have, shape function, which would take all of the layout at once.
Well, I'm confused here. So first point is that, okay, so where do you have your existing draft of this documentation?
Well, I have one, but it does different things. So,
okay. Well,
I have one in Dropbox.
Okay, all right, okay, fine. Where is it? Where is it?
In code development.
Maxime code?
Yeah, hypergraph plot documentation, just above it.
Okay.
So
how can I run this? Does it run? Does it run right now?
No, it's just documentation. It doesn't.
No, but how do I run the function? We've got an ordered hypergraph plot function, right?
No, we don't. We have the old one.
Yes, I understand. I understand, but I want to run the old one.
Well, it's in the set replace packet.
Okay, so I should have it here. So I have ordered hyper.
Yeah.
But for some reason I don't. So here, if I run this, okay. So Sushma, did you by any chance find a random hypergraph thing?
What do you mean by find a random hypergraph?
What is this? Is this Ed? The heck is this?
That is isn't it random rule signature random?
Yeah, but I think this is basically, if I say random hypergraph, then that should take a signature, I believe. Let's look at random graph. And because that's the number of nodes, S is the number of nodes here, I
Yes.
believe.
Yeah, yeah.
And so rule signature will be a thing that is of the form let's see, rule signature. Yeah, that's the number of edges, right? I mean, that's basically the number of edges. It's the number of edges right? N vertices, N nodes. Okay, so this case would be E edges, each of arity A, right?
Yep.
Okay, and that's the more general case. So let's just get that. Okay, so this is, I'm just trying to get a random hypergraph so I can test things out. And meanwhile,
Can't it be a list of edges and arity?
it absolutely can be. Generates a hypergraph with N nodes and E hyperedges of arity A. Okay, so now the next case is random hypergraph N, and then it's E sub 1, A sub 1, E sub 2, A sub 2, etc. Then nodes and E sub I hyperedges of arity A sub I. Ack. Doesn't this have a command key equivalent? I thought it did. 2 points. Why doesn't it say what its command key is? And second point, I think it has some kind of weird extra border on this thing. Go ahead, what were you going to say?
I see that. I think it is the same as what we use in Docker tools.
I was just doing that. It's option
Didn't
T.
work?
Yeah, it didn't work.
Okay.
So we might want to check into that. Okay.
Yep.
Yeah, it just turns into that. And that brings up the typography thing. I think I may have to have loaded DocuTools, which just kind of destroys the point because it would do that anyway. Okay, but okay, we're going to generate this random hypergraph in a second. But then for hypergraph plot, okay, here we go. Okay, so the edge type, we might give as a second argument to hypergraph plot, or it could be part of the hypergraph. Does that make sense?
Oh, you think it shouldn't be an option?
I guess it could be. I guess it could be.
I mean, I guess in most general case, it could be either just a single thing, in which case all of the edges will be that type, or it could be list of rules with patterns on the left-hand side.
Well, it could also be that every edge self-declares itself.
Yeah, and that's the most, the sort of way.
In which case, that's the setting, edge type is automatic.
Yeah. But list of patterns might be useful if you want to, for example, make all three edges one type and all 4 edges another type.
Okay. I think that's less likely. I mean, I think we are going to want to highlight things. I mean, does the whole graph highlighting mechanism work on this? Because I think that's going to come up.
But it doesn't work right now.
Okay. All right. What else do you need in order to be able to actually, I mean, so hold on a second. Did I let me just write this. Okay. So this is a varity that, and so all it is, there's no rule here, right? I don't know why he's got a rule here. Oh, that's because it was something else. This is simply a varity A, so it's simply random integer, 1, n, and then it's edges, so that's the number of edges. So I think it's just this, isn't it? So it's random hypergraph of, and then it's random hypergraph has got to have a second argument, which is the type. So random hypergraph of the n, the edges, let's say 20 edges of arity 2. Looks reasonably convincing, although it should probably be wrapped in a hypergraph, right? Yeah. I think there should be a type here.
It doesn't guarantee it's going to have 10 vertices though.
That's a good point. Well, there are graphs you can't get. I don't know whether does random graph guarantee that? Okay, so let's try a case of that. Random graph, 100 vertices and 5 edges. Oh, I see. In this case, it will have singleton edges, singleton vertices, right? Is that true? They just don't have any connections.
That's unavoidable.
Well, I understand, but in the hypergraph case, I'm not sure that we should allow that. I don't think we should allow that by default.
Yeah, for set replace, it doesn't make any sense to have vertices without edges.
Okay, generates a hypergraph with at most with E hyperedges relative to A and at most n nodes. Isn't that correct? I think that's correct. So here, okay. So now, well, we can do it with the arbitrarity here. In general, I guess we could have sort of random arities, but this is I know that it should be a dot, dot, dot. Let's not worry about that. Okay, so it's a hypergraph of, and then it's mapping over the signatures, if I'm not mistaken. Yeah, it's just taking this thing with the edge count as #1 and the arity as #2, and it's mapping that. It's actually applying that to signature, is it not? And then it's catenating the result, I claim. Okay, so that's the 5-2 case. And let's add a 4-3 case. Looks about right. You agree?
Yeah.
Okay. Okay, so now let's go ordered hypergraph plot of I got to do say first of this because we're not supporting that yet. What? A list of rules? Why?
We just took the first edge from it.
No, I
don't think we
didn't.
should have first there.
Oh, wait a minute. I hadn't evaluated this. Okay, that's what I was expecting. There we go. Okay. And now how do we do the, okay, so now let's look at how we do the labeling. Okay. How do we do the labeling? Hello? Still there?
I can
I
hear
mean, it
you.
probably works already.
Okay, well, let's just try it. What should I do here?
When you try vertex labels, goes to automatic. No, labels, not labeling.
Okay. Okay. All right. Okay. Okay. By the way, so another thing that should be on our guide page is rule plot.
Yeah, that's your code, by the way, for hypergraph plot.
Oh. Well, hopefully you've got better code.
Well, it's in development.
I mean, the case, how do I get my code to have those things in circles? Do I say plot theme?
What do you mean in circles? Oh, I'm not sure. I mean, it might work.
I didn't. That's what I thought was going to happen. Okay. Just a minute. Let me just okay, wait a minute. Visual representation of a Wolfram model rule. Okay. Okay, but anyway, so what decisions do we have to make here? So we're trying to have hypergraph plot.
Well,
So,
the decision I mean, the thing I was stuck on for such a long time is that I was trying to reproduce behavior with, you know, edge shape function and vertex shape function, this sort of things, which I now don't think is a good idea.
okay. Well, okay, but all right. But listen, the things we know we need the rule plot case, we need this case. I mean, so if I were to just take okay, so is there any other code that I could try using here? Because what we need to do is just okay, what is going to be involved in finishing this? So we've got method options here. Okay, let's look at your stuff over here.
No, it wouldn't be a method option, it would be graph layout.
Arrow, open polygon, or whatever. Is that right?
Well, okay. Yeah, that's okay. That's one of the things we need to talk about. So for the edge type, we have cyclic or ordered edges.
Mm-hmm.
And then graph layout.
By the way, we also have
able to take
the unordered case, which is what that other type of graph plot is supposed to be dealing with.
Yeah, but the point is that graph layout should take combination of edges of different types and it should do something with them. So now we have the problem that we want to still draw polygons, which is essentially cyclic layout, but they should be drawn not as a cyclic but as ordered edges. So I'm wondering what is the right way to specify that.
I don't understand the case you're talking about. So look, the cases that I know of, okay, so look, possible it isn't really graph layouts, possible hyperedge layouts, right?
No, they're graph layouts.
No, they're not.
First of all, edge layout is part of the graph layout.
Yeah, but edge layout is a different thing from this specification of how to draw a hyperedge.
Wait, edge layout specifies where the boundary of the polygon is going to be.
Yes, but that's not this. This is it going to be a filled-in brain? Is it going to be a polygon? What is it going to be?
But brain is a layout because it's not, you know, edges of the polygon in different places in the brain.
But I thought we were going to do something. There's a completely different issue, which is it using spring electrical embedding or is it using something completely different for its overall layout, right?
Well, yeah, so what I think it should be doing is that graph layout should either take options, I mean, like spring electrical embedding and so on, which would essentially turn hyperedges into sets of normal edges and then do the layout as usual. Or it can take brain electrical embedding, which is a completely new thing. And it does both vertices and edges simultaneously.
Okay. Okay, look, okay. We've also got the issue of the hypergraph plot with multiple hypergraphs, right? With a list of hypergraphs. Am I making sense? I mean, that's a different issue. That's trying to deal with making sure that they are agree, right?
Right. Yeah, so one thing we do need to have here is that hypergraph plot should have vertex coordinates option, which should allow automatic in there somewhere.
Okay.
Because otherwise we can make rule plot work.
No, I understand. But listen, look. Okay. What we've got to do right now is to get this working with the generalization of this, right?
What do you mean by generalization?
Well, I mean that it deals with self edge, self loop edges.
Right. Yeah.
Okay.
Yeah, that's what I'm working on right now. I'm trying to make minimal case with the least amount of options which would do that.
Okay, fine. All right. So now we're trying to get a generalization that will deal with other ways of. I mean, I think we should have an option called, hyperedge rendering or something. Or hyperedge. It's not even style. It's hyperedge rendering. And that
it's similar to edge shape function, except it should take all the edges at once.
Well, then it's not similar to edge shape function. I don't think. Do you think it should take all the edges at once? I think there's a separate thing.
Yes, because there's interaction between them.
No, I understand that, but what I'm saying is there are these different cases. Do you want the hyperedges shown as polygons, brains, your curve scheme, or what? Right? There are different schemes. And we could call it hyperedge theme, hyperedge rendering theme, or hyperedge theme.
Wait, there's separate issue. The first, there is a layout which just defines a rough shape of the whole thing.
Yes.
And what I think what layout should do is it should return a list of rules with graph elements on the left-hand side and geometric shapes on the right-hand side, such as lines and polygons. And then the rendering function would take those lines and polygons and turn them into something nice looking.
I don't understand this at all. Look, we've got to bank switch the thing. We got a few specific layouts that we think are going to work, right? Like curve, for example, right? This edge layout idea here.
Yeah, so they're not rendering functions, they're layouts.
No, they're not. Because a layout is where do you put the nodes?
And edges.
Fine. but that's a different problem from whether you draw these things with, you know, with something like a membrane like this, or whether you draw them with some kind of curve.
But
right?
membrane is a different shape for the edge.
It's not. Look, what does the edge
It
shape
is.
function do? Okay, what does the edge shape function do?
Well, it takes a line and it figures out how to draw it.
Okay.
It doesn't take just 2 points, it takes a whole line. And the line is produced by the graph layout. And there are different options of which edge layout to use.
By the
Which
way,
is the
we
right
should
thing to do
stop.
because sometimes.
Sorry. Hold on a second. That we should stop using dash greater than in documentation. It's just silly. That's an issue for Sushma that she could send to TNU docs.
Should it? I mean, should it like look like a rule? Yeah.
Yeah, it should just look like a rule. Okay. All right. So what are you proposing? You're proposing, because it can't be an edge shape function because it has the wrong things. It's given the wrong stuff.
Yeah, and it's not given enough information.
Where does it say in here?
And also in the brain electrical embedding case,
wait.
graph and edge layouts are computed simultaneously.
In which case?
Brain electrical embedding.
Okay, but I'm telling you, we shouldn't try to do it that way. What we should do is, if there's, look, we need something which simply says, look, what is the overall scheme we're using? That's all we should do right now. We shouldn't try to make something which has a completely general set of very specific functions. We should just
yeah. So
pick...
that's what I. Yeah. So that's what I want to do. So I will have graph layout.
Yeah.
Which would either take spring electrical embedding or something, or brain electrical embedding, and then there is graph shape function.
Okay, that's already too complicated.
Like
that's already too complicated. We want a single option that determines, are we using polygons like this in the best possible way of doing the polygons, or are we using...
Well, then we wouldn't be able to change the color of it.
Well, we'll have a separate thing, which is just a styling option. But we need something which is a single option.
Because...
Okay, look, we need a single option, and we can have many names for, you know, many different single bank switched options that deal with our optimized cases. Because going in and specifying in detail how to deal with self edges, how to deal with this, how to deal with that, it's complicated, and I don't think we should do it yet, unless you have an obvious scheme for doing it. I mean, is your scheme for doing it?
Yeah, I don't think we should do it. I think we should just split it into 2 parts. The layout and the rendering.
Fine, but then we need a single option that determines our optimal way of doing branes, polygons, curves. Make sense?
Yes, and actually rendering has nothing to do with it.
Okay, I'm totally confused.
Just layouts.
What are you proposing?
So what you're talking about now, these are just different layouts.
I don't think so. I think they're different renderings. I mean, I think they're showing, you know, is this being shown like this? Is it being shown? Okay, what are you proposing? What are you proposing?
Okay, 2 options. Graph layout and graph rendering function. I mean, I don't know exactly how it should be called, but something like that. Graph layout will determine the shapes which we need, such as, you know, points, lines, and polygons.
No, that's wrong. Graph layout is an existing option that does something different. So we can't use that option for that purpose. right? Graph layout is is an option that determines how what the embedding is supposed to be.
Yes, including edge embedding.
Yeah, embedding, not the same thing as the type of rendering, whether it's polygons, branes, whatever. It's not the right option for that. That's where we will put.
How is distinction between polygons and branes different than distinction between different ways of draw multi-edges?
That is what it is. Look, listen. Graph layout, we could perfectly well have a, whatever it is, I don't know.
There is edge layout.
I'm sorry, what?
There is edge layout.
Yeah, but it's not relevant. Look, graph layout is the overall layout of the graph, where the nodes go.
And edges.
Fair enough. And components. Okay, vertices, edges. Okay, it's
yes.
Where they go. Where they go. Not how they are rendered.
Yes,
where they go.
the boundary.
Yeah.
And polygons and branes have different boundary.
Yeah.
Therefore, the graph layout, not rendering function.
Okay, look. If what we're going to do is to have, right now, 3 options for graph layout, right? I don't particularly like it. Because I think that's an orthogonal thing. Whether we do the layout of the nodes using, circular embedding, for example, we could perfectly well have a layout of nodes that is circular embedding, but nevertheless use, have polygons that represents, well, maybe we couldn't. I don't know. I mean,
well, actually, the graph layout can be specified as a list where you separately specify vertex layout and edge layout.
I understand that. By the way, we should accept.
So we could say vertex layout goes to circle embedding, and edge layout goes to brane electrical embedding.
Fine, but how do we render the hyper edges?
Well, the layout would return polygons.
I don't understand. Look, the vertex layout, you put all the damn vertices on a circle, right? That's what circular embedding does. That has nothing to do with whether you're rendering these as splines or polygons or anything.
But it's not the full embedding.
What's not the full embedding?
Vertex circle embedding. It's only 1/3 of it.
Yeah. But edge layout is again a different thing. It's talking about, well, I don't actually know what where are the edge layouts here? Do we have possible edge layout settings here?
Yes, there are 3.
Where?
Well, at least 3.
Where?
On the bottom of the screen right now.
I see. Okay, but that's edge layouts. It's a different thing again. It's the thing that you get.
How is it different?
Because it's layouts. It's talking about.
The only difference is for 2 edges, we don't need polygons because they're too short.
Yeah, I know. Right, exactly. Exactly. It's a different thing from this because these things are relevant if you, for example, have 2 edges. You certainly can use these. I wouldn't be surprised if the characteristics of these things, I mean, it needs to be a different option. It needs to be something different. I mean, you might want to say.
Why?
Because
it does the same thing.
It doesn't. A 2-edge can work with any of these. A 3-edge has to be defined differently.
Well, the values are different, but it's still edge layout.
Well, not if you want the 3 edges to be rendered differently from the 2 edges. It's not
well, but then you can say, what if you want edges in the same graph be rendered differently. I mean, it's also valid question for two vertex edges, because then you can say I want some edges to be
Right,
rendered one way and some edges rendered
Bottom
another way.
line, I don't care about all these sub options. Right now, we have the problem that we need to actually get hypergraphs rendered, okay? And we have one scheme that is our preferred scheme. We have a couple of other schemes that might be useful for looking at particular hypergraphs. We need something that doesn't involve resetting 6 options to switch between those. What are you proposing?
Yeah, these are just different graph layouts.
Okay. All right, fine. If that's what you want to do, that's fine. Okay, what are we going to name the graph layouts?
Well, let's see.
Okay, so the
hypergraph
question. Plot has the following options. Okay, what's the default for graph layout? Automatic. Okay, possible settings for graph layout.
Yes, automatic in this case would be vertex layout goes to spring electrical embedding and edge layout goes to regions or polygons.
Okay. Possible settings for graph layout include okay. So what are we calling them?
Okay, so for
I personally think
there is
one of them, I think we should default to the spring electrical thing. So one of them is called polygons. I mean, we already did this over here. One is called polygons.
No, it's not polygon. It's edge layout goes to polygons, and
No,
vertex layout goes to spring
no.
electrical embedding.
No, I'm telling you, we've got to have a single option for graph layout that does the main thing we want, not 2 separate sub-options. So we can name it something more complicated than this, but we need
Yes, and it's automatic.
No, because we want to be able to get also. Look, okay. If we want to be able to get, for example, your curves thing reasonably easily, so you're suggesting that we then say, to get your curves thing, we would say vertex. You're proposing that we would say vertex layout goes to spring electrical embedding, edge layout goes to curves. Is that what you're suggesting?
Polygons.
No, no, no. Your case, not the default case. Your case. The case of your curves idea.
Oh, yeah, I think so.
Okay. I mean, that's extremely heavyweight. We need a single name.
Single name which would define
exactly.
both.
That's what I'm saying. So what should the single name be? I think the single name.
What do you think it should be?
What? Well, I don't think it should be the. Okay. I think it's an orthogonal thing. How the vertices. Oh, whatever. Look, why don't you put it in like this, and then we'll come up with the names, okay? Just make sure the automatic thing is polygons.
Okay.
If you put in this case.
Yeah, that's what was like. That's what I was planning to do.
Okay, fine. Okay. So let's look at the other things here. Okay. So we need to support presumably the following things need to be supported. We need to support in hypergraph plot of graph can be any of the following. Why isn't there a one-column table here? There should be.
Okay.
Maybe you can just delete a column actually. Okay, hold on. Well, actually, we don't need a one-column table here. Well, it could be an explicit list of hyperedges given as lists. Okay, and we also should support the case graph, just for the hell of it. Okay. So now how do we specify whether this is intended to be in hypergraph plot? If we give this form, okay, how do we say whether it's intended to be an unordered hypergraph or an ordered hypergraph or whatever else? You understand my question?
Yes, I mean, we can have the edge type option.
No, I don't think we want to do that because does graph plot have a second argument?
Yes, it's edges. Oh,
No,
actually, no.
no, it doesn't have a second argument. I think we should give this a second argument that is the type of hypergraph. I mean, we can also put it in an option. By the way, graph plot should surely allow a list of graphs, which it renders, you know, in some analogous way.
Okay, I'll let Charles know.
A list of plots, a list of analogous plots or something, of corresponding plots. And then we have hypergraph of generates plots assuming hypergraphs of the specified type. Okay, so now how do we get back to the original? Oh God, you see, it's just not right. It's just a bad idea because okay, what setting do you expect that original thing with community plot, that is currently in Hypergraph plot? What setting do you think that should have in your vertex layout, edge layout scheme?
I just lost internet connection for some time.
Okay, I'm asking you, the thing that's currently in the function repository, right? Still there?
Yeah.
Okay, that thing that's using community graph plot, okay? What do you think its setting to retrieve that functionality from Hypergraph plot? What do you think the setting should be for Hypergraph plot to achieve that?
Well, it should have a special graph layout, which, I mean, I'm not sure what it is.
Okay. Well, so it's a named graph layout, but should it be given in terms of vertex layout and edge layout? Or should it be a named specific?
Yeah, both.
Well, no, what do you mean by both? What do you mean by both?
I mean, they both could have a single name, but they're both important.
I understand that, but what do you specify? The point that I keep on making is I don't think you can factor these things in a useful way most of the time. See what I'm saying?
Yeah, it's a good point. I mean, maybe not.
Okay. That was
But
the point
the
I've
only
been trying to make.
problem, if you are not factoring them, you would not be able to, for example, get polygons with a spring embedding.
Well, listen. Why don't we try and factor them like this? But we also need to provide cases that are unfactored, right?
Yeah, I think it's a good idea.
Okay, fine.
Just need to figure out how to call them.
Yeah, I know. Okay, so possible settings are spring electrical polygons.
Oh yeah, that's pretty good actually.
Okay.
Yeah,
So
then
then
we can
also
spring electrical curves.
okay. And then we have I mean, it's kind of like a Venn diagram, this other one. Community regions.
I think it's pretty confusing.
Okay. Well, what would you call it? Venn diagram? It's not a Venn diagram.
Well, for edges, they are similar to polygons, except they extended, out from the vertex.
But it's not spring electrical at all, is it?
Yeah, there's no spring electrical also.
Enclosing regions or something.
Although I don't see any reason why it shouldn't be spring electrical embedding.
Well, it effectively is. Community graph plot is doing something like spring electrical embedding.
Okay. I didn't notice that at all in this
I'm sorry?
plot. I didn't notice that at all in the function. I mean, just try function repository hypergraph plot with reasonably large graph. It doesn't look like spring electrical embedding at all.
Okay. Why did I have that? There we go. Okay, so you say if I do this, let's say I do it with a, okay, so I'm going edge list. Let's say I do a random graph. The heck is that?
I think you need list instead of unordered edges.
Oh God, how do
So
I get
just
that?
apply list to this edge list.
Okay, I don't know what that silly nonsense is over there.
Yeah, see, that's not spring electrical embedding at all. Just put them on a grid.
Well, that's really weird. I mean, let's look at the code. Okay, there's the code. Okay, so it's a community graph plot. So the second argument of community graph plot I see. That's giving what the communities are. See what I'm saying?
Yeah.
Okay, so let's look at this. And now we select that list queue. Okay, it'll do nothing. Okay, so now, community graph plot of this, what's this delete duplicates?
I think it gets a vertex list.
No, it doesn't. What does it do?
No, it is a vertex list. It flattens the hyper edges and then it makes a union of them.
But that's not what it needs. I mean, it's just garbage.
Well, the first argument for the graph is a vertex list.
Well, what's the second argument?
Edges.
But it's giving nothing there for the edges.
Well, that's why it doesn't draw the edges in an ordinary way. Oh, I see. That's why embedding doesn't work, because it draws this graph as a pack-in embedding. It's just a graph of individual vertices. There are no edges in it.
Yeah.
Yeah, that would explain things.
Why is it using community graph plot at all?
To get regions, I guess.
Well, so what do we think this should say? I mean, in other words,
well, it should turn hyper edges into, so it should turn each hyper edge into a complete graph. And then, make union of those graphs, and then just do edge shape function goes to none or something like that.
Okay. All right, well, let's try that theory. I mean, I think this function is really pretty weak. So, I mean, we can try that theory for a second, okay? So you're saying if we take a random hypergraph like this one here, let's see what we have here. Why does this not? Where do we have this? Oh, hypergraph plot 03. Okay. All right. So what you're saying is we take the hypergraph like this one here. Well, actually, let's take a slightly more elaborate random hypergraph.
So let's have at least 3 edges.
I mean, 3 dash edges. Right.
Yes.
Okay. Now, each one of those we want to make
a complete graph.
right. So is there a way of doing that with a complete graph on those edges?
Oh yeah, that's a good plan actually. I don't know if it works.
Well, but we can make a complete graph by just doing all possible pairs, right? Tuples.
Yeah.
We just tuplify the thing.
Right.
But now, what do you want to do? You want to make, okay, so we can make tuples of each of those. Then what?
Yes, and then make graph union of them.
Okay, all right.
Which
So what
would
you
give us
say,
a normal graph which is similar in structure to this hypergraph.
all right, okay. So complete graph approximation.
Yeah, but I will have to leave in about 10 minutes.
Okay. Hypergraph of data, colon equals, and then for each data element, we're saying tuples of that element, comma 2, and then it's graph of that. Okay, and then it's graph union. I don't remember what the graph union, what graph union's structure is. Okay. Apply graph union to that mapped onto data.
You should have 2 instead of mapped.
What's that?
You have 2 instead of mapped. So replace 2 with add.
Okay. Now what? Now how do we get each complete graph? No, what we really want are the weights inside those complete graphs. I don't understand what we do here.
Well, we don't need any weights. We should just do community graph on this. Now we do the same thing as the function repository function does, except for empty edges we use the same we just got right now.
So you say we do community graph plot of that. That's wild.
This is weird. Well, yeah, but we need to specify what the communities are.
And what are the communities? The things in the edges.
Well, select hypergraph list Q. Isn't it just hyper edges?
Yeah, it's just what's in the edges. It's exactly what's
Yeah.
in the edges.
Right. I don't know why this one doesn't any selecting at all. But...
Okay, and then we've also got this thing here. I don't understand that most of tuples thing. Do you understand that?
Not really.
Okay. I don't understand what these regions are then.
Wait, is it? Can you run the same thing in 12? Maybe it has to do with the same problem. Yeah. Yeah, I think community graph plot is just broken in current build of 12.1.
Well, this is quite beautiful, actually. I mean, I don't know what those self loops are doing, though. Those are because the tuples.
Well, it doesn't handle self loops at all.
No. These tuples, right, in the complete graph, we should select out the unequal tuples. See what I'm saying? See what I'm saying? If I put in here, select apply unequal, I claim this will do the right thing. Yeah, there we go.
Well, yeah, except now we have no way of knowing where the self loops are.
There aren't any. Listen, tuples is not giving a complete graph, right? It's giving a complete graph with extra ears on it, with self loops. Okay? See what I'm saying? It's incorrect. It's not giving a complete graph. If the nodes there are 5, 7, and 11, it's giving 7 self-looping to 7, which is wrong.
Oh, okay, yeah. Good point.
Okay.
But we still lost loops, which
I agree. We've
118,
lost.
for
I
example.
agree. We have to look at the case where there is already a repeat in there.
Yeah.
Okay, but in this case here, whoops. In this case here, which edge is which? Do we understand that? Do we know that? See what I'm asking? I mean,
Can you do vertex labels?
yeah. In the community graph plot.
Yeah.
Okay, 5, 10. Well, that's somewhat reasonable, actually. Here, let me just
Yeah, that's what it was supposed to be.
Right. So let me just open this file in 12. I assume you can pick up all the stuff from the Dropbox before you get on your flight or during your flight, yeah?
Likely I can.
Okay, so here, I got to get random hypergraph in here, but okay, so this is what that was supposed to do. So the only stupidity is we actually want to put in here edge. We want to get rid of the edges, right?
Yeah.
How do we do that?
I mean, we could just have edge style goes to transparent.
Why don't we just say edge style goes to none? Turns out we can't do
Probably
that.
because it's not a graphics directive.
Oh, I see.
Wait, that doesn't do anything.
Okay, you think it should be transparent.
Yes.
That seems like a hack to me, but anyway. Okay.
Well, it's not a hack because edge, I mean, the lines are produced by the edge layout, which is too late by this point.
Do you understand what this do you understand what this thing is doing here?
Well, can you run it separately?
What the hell is that? What is that thing? Oh, those are color swatches.
Yeah.
Those are color swatches. Oh, I see. What this is doing is it's taking, but I don't understand why that is. Okay, community region style. We need to know what community region style is.
Oh, wait a second. Does it only have 7 colors?
I think it
What
only has
happens
7
if you have
colors.
more than 7 colors?
Cyclically use this for successive communities. That's just completely silly. Okay, so how many?
I would use something like color data 97 for this.
Yeah. But so that's actually quite silly. I mean, it should just be a list of colors. So,
right.
Does this have a function that's also possible to use? No. Okay, so how many communities are there here?
Ten. But
How do we know there are 10? The maximum of 10, right?
well, it's a number of hyper edges.
Oh, I see. That's right. So table of length of data, which is the number of hyperedges. And then what are you suggesting? Opacity.
Well, it's color data 97, comma the index. No, index inside of the color data.
I don't think it's quite the right colors, but
No, that's what least clauses you use.
okay. So to get
Yeah, okay, I need to leave now.
okay. See you later. Pick this
Okay,
stuff
see you.
up. You might be able to see. We'll send you mail if we have other stuff. Okay.
Okay,
Okay.
okay, see you.
Have fun. Bye.
Bye.
Okay, let's try. Random hypergraph of 100 nodes. I don't quite understand why there are ones here that just have 2. That doesn't look right. See?
Yeah.
Oh, it's 118. It's a self loop. Okay, so we're not handling, this doesn't handle self things well.
Mm-hmm.
I don't know how it should render. How should it render? We've got 118 in there. I mean, we could render it with some kind of extra. What the heck should we do? I mean, this is just showing like a Venn diagram. It could be.
Can we have, like, I don't know, a weight to 1? But probably it won't work if 1 is in other community.
Well, we could do.
No, but it won't be clear if one had another
see.
community.
Yeah, if it is shared with another hyperedge, if one is on another hyperedge as well.
Yeah.
Let me think about this for a second. I mean, what we did before with the polygons is we have that weird fold back thing where it's like a piece of paper that's folded on itself.
Yeah.
I think that's the only way to do this. Okay, let's just try a bigger one here. So let's try one with 100 nodes and let's say 200 hyperedges, each a triple hyperedge. Let's now say what are we calling this one? We're calling it, we could call this region hypergraph plot. Oh dear, it's thinking. Well, let's think. Oh, there we go. Blah. Who knows? Well, here, if we take down the number of hyperedges, so like just 10. Oh my gosh, that's really funky. So I see. So there's very few that overlap there.
Yeah.
Okay, so let's imagine we have 10 of those. I mean, this is a really pretty bad visualization technique, I think. That's not completely horrible.
Mm-hmm.
I mean, I don't understand why these things have colors. That's just silly.
Yeah, and it's not clear how it chooses the color as well, right?
It's not clear to me. I mean, I think it's choosing it by the, you know, the colors of the communities, so to speak. Hold on one second. Just a second. Just a second. Okay, sorry. Okay, we might as well just fix this. Hold on a second. I'm sure it's easy to fix. Well, he says it's easy to fix, but where is the style for? Well, it's somehow, oh gosh, I hate this documentation, which doesn't actually explicitly give, what is the thing for vertex styles? For graph, that looks wrong too. That should have a C also that goes to, gosh, we put that in 7 years ago. Okay, vertex style. Just a second. Okay. Okay. So if I say vertex style arrow none, just a minute. Just a minute. Vertex style. Oh, come on. Just a minute. Okay, what happened here? Vertex style. What the heck is the default vertex style? Again, badly documented. Look at this. Why are there no... Well, let's see what happens if I say vertex style arrow automatic. What the heck is it doing? Oh, gosh. So, can you complain to people, please?
I'll ask.
And also, these things that say related guides, graph properties, or properties, that should be removed.
Okay.
This thing that says properties, that guide/properties should simply be removed.
Okay.
This is really pretty dumb. I mean, so this, if I say RGB color, if I just say gray, that does make them gray. It's not completely obvious that having these different colors for these things is useful. Is it?
Yeah. No, I don't know. It does not seem useful actually, because we already have the edge style.
Yeah, exactly. I mean, maybe a very, very, very slight tinge of color. Let's say opacity 0.1 or something. I think that's better. It's still not great. I wonder what will happen with this. Oh, it would take forever. Forget that. I wonder whether this is some crazy combinatorial thing here. Oh, go. Well, that's comparatively non-useful. And why does it have... Okay, let's do this. Let's see what happens if I go... Okay. That's not completely silly there.
Yeah, I like this better.
The... I mean, this is really hard to read. Let's be realistic. This is in the category of what on earth is going on here. But it's not, I mean, it's not sort of, it's not obviously stupid, but it's just definitely not. All right, let's put this. We should probably put it in here. Well, actually, if you can just send mail to Max and just tell him here's the thing that we think is somewhat reasonable, and if he can incorporate that as a layout option.
Okay.
Okay, so then we've now superseded. So now we have to have a name, however, for in hypergraph plot. I mean, I have no idea whether it's underlying, it is Spring Electrical or anything else. I mean, I don't know what it is, but I think it should be called Community Regions because I think it uses community plot.
Yeah.
Graph plot. Honestly, the way that this documentation should work, these should be thumbnails of some kind.
Those should be thumbnails where?
Yeah, I'm going to show you. So we take this, let's say we say image of that, and then we say image resize. Unless we can do that, I don't know if we can do that.
I think you could just do thumbnail, right?
Yeah. That's what I'm suggesting.
Okay. Okay.
Right in the documentation.
Okay.
I think then we have, there's at least the chance to understand what's going on. Otherwise, I think it's hopeless.
So if you go to community graph plot documentation, we have something like that, but the thumbnail is the first column, and
I
then
think that's the right thing to do.
Okay.
We can redo this if we want. Okay, let's just redo this for a second. Okay, let's put the polygons there. Okay, fine. Okay. Graph layout. Setting for graph. Specifies particular layout methods to use for vertices, edges, etc. Okay, so you can just tell Max that we put that in there.
Yep.
Now, okay. Whoops. Let's see. Possible, but I don't know why there's so much space before that mail. Who knows? Okay, possible types of hypergraphs. Let's see, it says, assuming hypergraphs of the specified types. Possible in this thing here. Possible types of hypergraphs to assume include. Okay, and this is where we basically say the same thing that we had in the previous hypergraph documentation. Not that one.
No, it's Hypergraph Pod documentation notebook.
Okay, so a bunch of this stuff applies. Well, actually, it's just this. Max is suffering from the lack of articles in Russian. Although he does pretty well on them, actually. Unless I wrote that. Got it wrong myself. Okay. I think this is a good start for this.
Okay.
All right. If you don't mind, we could keep going on a few of these other functions. Would that be okay?
I would like to go soon, but I can go on for like another 20 minutes.
Okay. All right. Let's see what we can do.
Okay.
All right. So we've got hypergraph here. We don't put a period at the end of these, right?
No, we don't.
Oh boy, we got a bunch of other. Let's see. I don't know what we do with if we have this hypergraph thing. I guess this will become a function repository.
Object, yeah.
Yeah, which is not the best, but it's okay. I mean, actually, the thing can format. It probably should format in a special way, right? I mean, Max knows how to write those summary box formatters. Why doesn't he format the hypergraph with a summary box? Or we can format it with a default, with its actual, we can format it with its display, you know what I'm saying.
Yeah.
For a small hypergraph, we can format it with its actual hypergraph plot.
Yeah, okay. So do we still need a hypergraph function repository entry?
This?
Yeah.
Yeah, we do, because it's got to have a, oh, do we need an explicit function repository entry for it? I think we should have one, because although it won't do very much, yeah, we should have one, because you might need to enter a hypergraph, right? So it has the edge specification that you would need. Right, so all that would happen is it only really has a format value, and it might check the types. Okay. All right, let's see. And by the way, that needs to be in our manifest over here. Oh, we did put it in the random hypergraph. Also, okay, and we need to figure out what the other reason we need this in the function repository is so that we can define up values for it. You know what I'm saying? So we can get things like edge list and so on to work on it. We should plan at the very least for 12.2, if not for slightly sooner than that, to get a hypergraph into the system. Because we're going to be just doing oodles of things with hypergraphs probably.
Okay, yeah.
Plus, as these other guys, like the chemistry people, want hypergraph as well.
So, I mean, what I would like right now is if we could go over the function repository entries that we talked about, and if there are any which I can go ahead and have somebody clean up, and then, somebody who is not Max and Jonathan, by the way, and have them added to the function repository, then I could, do that.
I think we can do that. Yeah, I think we can do that. But I think that okay, look, the conflict between find canonical Wolfram model and Jonathan's hypergraph isomorphism needs to be cleaned up.
Okay, yeah, that's on my list, yes.
Okay, I'm trying to figure out over here. Okay, so this is hypergraph plot. All right, so hypergraph plot, hypergraph represent display. Okay, let's basically make By the way, presumably what will happen if I were to say, okay, so now what I want to do, and this is where things get kind of messy with, and this is where, oh gosh, that stupid thing disappears. Oh, yeah, all of this stuff. I mean, humph. Well, let's see. If I say first of %%, comma first of %, it should say false. Oh dear. Well, that's why we need ed's function. I wonder if Jonathan's run it on anything real like this. Okay, well, it did successfully return false. It just took forever.
Yeah.
Now, presumably what Ed has is a fast version of this, right?
Yeah.
So what we need to do probably is to do a big run on random hypergraphs and find out, you know, if Ed's thing ever gives the wrong answer. Because I don't see how Ed could know that without having, I mean, well, we're testing both Jonathan's and Ed's thing. Just do a big run, see whether they agree. And it's also might be the case that one of them gives no false positives or no false, like if Ed's one gives no false positives, for example, then we can run that ahead of Jonathan's one, even in Jonathan's code.
Yeah, yeah.
Yeah, it's just a bunch of bookkeeping to be done here. I mean, we've got, I suspect these string overlap things are ready to go.
Okay.
I also suspect these deterministic, non-deterministic Turing machine things are pretty much ready to go. Although, okay. I would love to get multi-way system in some form, even though we know we're going to update it. I mean, I need to look at, in the multi-way system case, some of these things down here, which are the combined evolution and causal network. We've really got to look at those more carefully because I really want to use those. If they're not absolutely incomprehensible, I want to use those to illustrate what's going on. All right, you should probably go.
Okay.
I am pretty much spoken for much of tomorrow, unfortunately.
Yeah.
But I may try and continue working on some of these things right now, just to, yeah, okay, fine. All right.
And I think all of us said, like Max, Jonathan, and I said that we are okay on Sunday to work pretty much any time.
Okay, all right. Well, I'm mostly available actually on Sunday.
Yeah, yeah. Emma put something for 11 a.m. so we could start then and see how long we go.
Yeah, okay. All right, okay, fine.
Yep.
Okay, sounds good.
Yeah.
Thanks a lot.
Bye.
See you later. Bye.